Welcome to Introduction to Aerodynamic Objects Tutorial 6, my first glider. And in this tutorial we're going to set up a glider with aerodynamic objects and learn how to undertake flight experiments. First up, we're going to set up and organise a free-flying glider model. Then we're going to use some flight experiments to find aircraft and launch settings for good gliding flight. And then finally we're going to simulate soaring flight in rising air. Our scene diagram looks pretty much similar to what it was in tutorial 5, but this time we're free flying, and the other change is that we now got a port wing and a starboard wing because we're modelling a plane with some dihedral, so we've got two separate wings on it. So here we are in Unity, and I've taken tutorial 5 and just saved it as tutorial 6 to get us started. So it's exactly where we left off. And what we've got to do is quite a lot of busy work to reorganize this so it's a free-flying glider. So the first thing we're going to do is create a parent to this, which is going to be the glider object. So I'm going to do right-click, create empty parent, and I'm going to call it glider. And following best practice, we want the rigid body to be at the top of the hierarchy of the object. So I'm going to add a rigid body to here. I'm going to set its mass to 10, and I'm going to remove the Unity drag. And then previously we had our rigid body on the rod, so I'm going to delete that from there. And this aircraft manager script. So really we're just transferring the kind of business end upper layer, and I'm going to add an aircraft manager script here, tutorial 6. So once again, this is asking for our center of mass marker. So I'm going to drag that in. And actually while we're here, I'm going to move the center of mass marker just up a layer there, so it's next to the top level. That's fine, it's moved. So rod was fine when it was a weather vane. Let's actually just call it a fuselage now. And we got our vertical stabilizer, horizontal stabilizer. I'm going to just group those together and call that tail. Come back to that in a minute, but the main work we've got to do is on the wing, and actually because it's completely different, the best thing to do is just delete that and create another one. So I'm going up to glider, create empty, and I'm going to call it wing. Shift Alt N does a new child as a quick shortcut, and I'm going to call that starboard wing. And if we were creating an aerodynamic object before, what we would then do is add the geometry, but actually we're going to add in some other layers to our hierarchy just to make it easier to manage. New, and I'm going to call that geometry. And now we're going to create our graphics. So I'm going to do right click, 3D objects, and a cube. But what we're going to do is offset this by 0.5. And so this means we're just building on one side of the aircraft. You can see why we've done that in a minute. We are going to have this semi-span to be 3 meters. It's going to be 0.05 centimeters thick. We're also going to shift it back half a meter, and the reason we're doing that is so that our root object for the wing is at the leading edge, and it's kind of good practice when you're doing aircraft models to use a reference point for all the dimensions, and typically the best place for this is the leading edge of the wing, and you make everything relative to that. We're going to have some dihedral on this, so by bending the wings up we get some aerodynamic stability and side slip, in the sense if the plane starts going sideways it'll tend to lift that wing up. And let's put in 8 degrees of dihedral. For some visualization, we're going to put a streak line on the wingtip, and that just helps us see where the plane has been. So if I go up to the starboard wing level, and I'm just going to create from aerodynamic objects, flow visualization, a streak line, and in ortho mode I'm just going to put it roughly on the wingtip. So that's our basic geometry. Now we need some aerodynamics. So first off I'm going to actually label that offset, that transform, so we know that's an additional one in there, and now we're going to put in the aerodynamics as we've done many times before. So I'm going to add aero object. We're going to have drag. We're going to have lift. Our rigid body is the glider. Velocity source is rigid body, that's fine. We've got a rectangular planform, let's use a rectangular reference area. What else do we need? Some visualization for the forces on there. Let's add in some arrows. So let's have a lift arrow and a drag arrow. Because this is moving faster than it was in the previous tutorials, it makes sense to scale these arrows down to the appropriate scale for what's going on. So I'm actually going to reduce the sensitivity by a factor of 10 so that we can see better what's going on. Great, so I think we've got ourselves a wing. Need to do all the same for the wing on the other side, but of course what we're going to do is just duplicate it. So if I'm on starboard wing, duplicate it and then rename it to port wing. And to get the geometry on the other side, what we have to do is just negate the offset. There we go. Dihedral's the other way, that's fine. And we set that to -8. That's gone up like that. And we've got all our other bits and pieces on it. So we've got a couple of wings. Having put those on, the glider's looking pretty good. Tail looks a bit funny now. It obviously started off as a weather vane, but normally the tails don't go down as well as up, so let's just fix that. So we go to the geometry on the vertical stabilizer. If we just make it height of 1 and offset it by 0.5, we will get a nice looking vertical fin. Next up, the nose looks a bit long on this, or the tail looks a bit too close to the wing, so let's sort that out. So if we grab the fuselage, we could actually just move it to wherever we wanted on here. That's a good position. I'm going to move it so it's around there, and in fact let's put it exactly as -0.6 back, so it's 0.6 meters back from the leading edge. Okay, our tail's got some angular displacement in it. Let's just sort that out. So if we horizontal stabilizer, geometry, and let's just zero that out. So when we're starting our testing, we're just starting at a 0. And the other thing I'm going to do on here is pull this out by selecting on properties. And just so we're absolutely clear what's going on, I'm going to call this horizontal stabilizer. So we can control the angle from a pull-out view here. Since we're doing flight testing, let's put some sensing on this. So what we're going to do is add a flow sensor to the nose. So if we go right up to the top of the glider, right-click, Aerodynamic Objects, Flow Tools, and Flow Sensor. Let's drag in the glider rigid body and drag the sensor itself right to the nose. And in fact, I'm going to use the transform for its velocity. So we're going to measure actually the velocity of this transform at the nose. It's already put a flow sensor arrow on it, and let's, as before the other ones, reduce the sensitivity by a factor of 10 so it's not too distracting. Okay, I think we're getting there. Our centre of gravity at the moment is on the leading edge, so at 0, 0, 0. From our previous experience, you can have too much stability, so if this thing's very, very stable, it's quite hard to balance. And a really good starting point for a centre of gravity position is actually on the aerodynamic centre of the wing, so at a quarter chord back. And so let's do that. Because we've got 0, 0, 0 as our reference, it's easy peasy to put it on a quarter chord, so I'm just going to put -0.25 there. And now our centre of gravity is going to be a quarter of the way back from the leading edge of the wing. Quite a lot of stuff happened there, and so let's do a quick check to see if we've done it right. So if we go up to our top level of the glider, we've got a rigid body, it's got a mass of 10. We have got a aircraft manager tutorial 6 script on here, and we've connected up the centre of mass marker. Currently our launch speed is 0. I'll tell you what, let's put that to 10. And the other thing I'm going to do is pull this out. So properties, and then we can control the launch speed from down here. Center of mass marker, that's fine. Fuselage is just geometry. Tail, and let's just check out what's going on here. So the aerodynamics, at the moment we have lift and drag. But okay, missing rigid body. So because we removed the rigid body from the fuselage, we need to reassign it. So that will be the same as on the other one. So I'm going to select both of those and drag in the glider rigid body. And whilst we're here, I'm also going to change that back to rigid body. We had it on transform before when we were doing some of our experiments, so it makes more sense here just to get the velocity at the tail from the velocity of the rigid body. What else have we got here? Wind and drag arrows probably getting a bit cluttered, so I'll tell you what, I'm going to disable those so we don't get in the way. And then our lift arrow, I'm going to make it a smaller diameter just so it's more in keeping, and once again reduce the scale by a factor of 10. Okay, I think we've done everything we need to on those. So tail is good. Let's check out the wing. Starboard wing, geometry, so offset aerodynamics. So we have got lift and drag models. We've got our rigid body connected to the glider. We've got lift and drag arrows. It's looking good. And this one was copied, so it should be the same. So we're good there. We have some streak lines on that wingtip, and we have some streak lines on... Okay, we don't have streak lines on the other wingtip. So let's move that across. Okay, so when I copied it, I changed the wing, but I didn't change the streak lines. So let's get on our port wing and change the sign of the X coordinate. And there we go, jumps across to there. Flow sensors on the front, we've connected up our rigid body. We have reduced the sensitivity by a factor of 10 so it doesn't get in the way. Okay, I think we've got ourselves a glider. So we're ready to set up our flight test, and let's put some assets in the scene to help with our flight testing. So I'm going to grab a ground plane from the prefabs, and I'm also going to grab Aeroman. So let's get the glider off the floor, and this may well be the first test of whether you've stuck everything together right. So if you select the highest level of the glider and grab it, it shouldn't fall to pieces when you move it. And absolutely don't have to do this, but why not? Let's make it so that Aeroman is our flight test engineer and he's holding the glider. Notice down there that little blue arrow is our gizmo for the uniform flow. So we've actually got the wind left on at the moment. So let's just go up there and let's turn our wind off. It's always better to test minimum wind conditions. And because we're going to need to change that later, I'm going to pull this out as well. So down here we have got our horizontal stabilizer set to 0. We've got launch speed of 10, we've got the wind off. Okay, I think we're ready for our first test flight. So let's step back a little bit. It's going to be launched in the Z direction at 10 meters a second, and let's see what happens. Okay, that wasn't bad. Everything held together. It flew forwards and it went a little bit, but then hit the ground. When you first build this glider, I can almost guarantee that there's some bit that you've left off and it won't do that, so you may have to go back and fix things if it doesn't look like that when you launch it. Okay, so we know that to generate lift, we want this thing to balance with a positive angle of attack, and we know we can do that by altering the horizontal stabilizer. So let's do -5. You may have just seen it move there. So now horizontal stabilizer is now pitched down 5 degrees, and so that will produce downforce on the tail, and it should allow this aircraft to trim at a positive angle of attack. Okay, let's see how this goes. Okay, look at that. That's a nice flight. So the difference between an aircraft that's not balanced and one that is, the one that isn't balanced just went a few meters and hit the ground. With our aircraft fully balanced, it flew beautifully. Fantastic. So since we're doing some flight testing, let's give it some more angle on the tailplane so it'll trim at even more lift. Let's see what happens. Okay, so that was interesting. So now it's actually trying to fly at a greater angle of attack, so we're getting more lift. But what we saw there is that actually there was sufficient lift that it started climbing and then it stalled. And we can keep going, so let's try even more. Yeah, and it doesn't go so far. So if we just go back to our sweet spot, which is -5. There we go, that's what a trimmed aircraft looks like. So now we've got the hang of our flight testing, I think it's time to put some cameras into the scene so we can see what's going on properly. So if we go to our all prefabs and drag the AO camera prefab into the scene, and let's set these up. So we've got a ground camera which stays fixed on the ground, but it tracks the aircraft in the sky. And then we've got an aerial orbit camera, which is kind of a drone cam that will follow your aircraft, but you can rotate around it. And then similarly, an aerial chase camera, similar as the orbit camera, but it'll just stay behind your aircraft. So these need just a little bit of setting up. So we need the target of the camera, so it needs to know what it's looking at. So I'm going to use the transform as the glider as the target, and then for this ground camera I'm going to stick it in front and rotate it around so it's looking that way, and the default distance I'm going to increase to around 20 meters. For our aerial orbit camera, same again, we need to tell it what it needs to look at and follow, and distance I'm going to set that to 15 meters so it stays a reasonable distance away. Chase camera, probably not going to be using that, but let's set that up anyway, so let's give it a target. The default camera on here is orbital. For our initial experiments, let's just change it to the ground view camera. Since we're now going to be using the game view, we need to do play focused on that. So now if we hit play, we have our ground camera filming the action. Fantastic. Okay, let's do some flight testing. Well, this is simulation, so we can do whatever we like. When we had it set to -15 on the horizontal stabilizer, it climbed and then it stalled. But what happens if we did that but just chucked it a bit harder? So now I'm going to throw it at 20 meters a second. See what happens. Okay, that was pretty exciting. So it did a stall and then kind of did a flip over and hit the ground. But that's pretty cool. So it looks like we just need to chuck it a bit harder. So let's just throw it harder, another 5 meters a second, see what happens. Okay, made it all the way around. Oh, look at that, smooth butter landing at the end. Great, so what we're doing there, we just changed the speed we launched at and it had more energy, and therefore it managed to get all the way around a loop. So at this point, wouldn't it be great if we had a camera tracking that in flight? So if we go to our cameras and switch our default to the orbital camera, and if we just check on here, what I'm going to do actually is enable auto orbit. So this means it not only follows it, it will go round it as well, and I'm going to set that to 30 degrees a second. Okay, let's watch that loop again, but this time from the aerial orbit camera. Okay, fantastic. If you're doing this and you're finding things are jittering slightly, it may be something to do with the time step of the simulation. For this project, I have actually changed my fixed time step. The default in Unity is 0.02, and for this bit of the project, I've changed it to 0.002, so we're getting 10 times as many time steps per second. It has some impact on the frame rate, but actually not as much as you would have thought, actually, depending on how much physics you're going on. Increasing the number of steps per second by a factor of 10 only reduced my frames per second by around 5 to 10%. Okay, so that's enough looping the loop. Let's go back to some more steady test flying. So I can set a launch speed of 10. I'm going to set our horizontal stabilizer angle of -5 degrees, and just remind ourselves what it does. Nice steady glide heading downwards. But looking at that, you're thinking, well, how about if we have some rising air? So if there's some sort of thermal with rising air, we should be able to stay in the air for a bit longer. So let's create some rising air. So on our uniform flow script, let's add a velocity of 1, but we're going to set the elevation to 90. And if we look carefully at our gizmo there, we can see our blue arrows pointing up. Need to be able to visualize those arrows, so if we go to our flow field arrows, let's make them a bit bigger, or quite a lot bigger. So let's do 100 by 100 by 100, and let's do 5 arrows by 5 arrows by 5 arrows, and let's increase the size to 5 and scale them to 5 as well, so all the 5s. So we've got a box of arrows there, and we have our velocity, wind velocity set as 1 meter vertical. See what happens. Okay, so we're just about maintaining altitude. So the plane is actually flying downwards, but the wind is going upwards, so we're saying just about even. Great. So that was good, but kind of be better if we stayed inside the world. So can we get this flying around in circles? And the answer is yes, and we're going to do that by changing the vertical stabilizer. So a bit like with the horizontal stabilizer, we altered the angle to change the aerodynamic balance. What we're going to do is here put a bit of deflection on our fin, so therefore the weather vane as such is going to balance flying slightly sideways, and that's going to make our plane turn. So what I'm going to do is just put in 5 degrees twist on there, and that should make, or push the tail to the right, so the nose should go to the left, so it should make a turn to the left when we launch it. Let's try that. There we have it, we're flying. Didn't quite make it back to level ground, so that's fine. Let's try adjusting the trim a little bit. So if we now just change it by another 3 degrees to -8, so that's going to be flying a little bit slower, a little bit more lift, and let's see if that's enough to keep us above ground. So it's climbed a bit more on the launch. So that's looking promising. We've just got a 1 meter per second thermal we're in there, and there we go. That is enough for soaring flight. It was kind of scratching around, not really climbing very much, but I think we have got sustained flight there, just with a 1 meter per second wind going up. So there's no flight control systems are in there, that's just pure aerodynamics and geometry. So it's because we've got a bit of dihedral on the wing, and we've offset the vertical stabilizer. The plane is always just flying slightly sideways, and that's making it go in a circle. And because we've got the deflection of the horizontal surface, that means it's balanced at positive lift as well. Let's increase the vertical speed to 1.5. So now it's really climbing. Okay, so in our next tutorial we are going to build some propeller propulsion. So we're using free lift from the wind here to fly. Next up in terms of building a fully functional aircraft is we need some propulsion. So hopefully see you there.